Okay, welcome to my YouTube channel. As promised, I have more questions on projectile. Just 3 questions. I believe this is the last question from the previous class. So let's dive into it. Now, a ball is projected. Now, the reason why it's a projectile question is because of the word projected. We need to take note of every keywords that are going to be mentioned in the question. Now, a ball is projected from a height of 20 meters above the ground. Okay, so for question 1, height is 20 meters. Okay, with an initial velocity of 0.4 meters per second. So it means u equal 0.4 meters per second. Now we're asked to calculate the horizontal distance moved by the ball before hitting the ground. Okay, so we are looking for S, which is the horizontal distance. We don't know. The last value that was given to us, the constant, means acceleration due to gravity equal 10 meters per second square. Now, irrespective of the fact that it's a projectile question, in question 1 we discovered that there is no angle. So how do we now treat this question? Now we need to bring in, when I started projectile, I told us there are some prerequisite topics that we need to know. Topics like motion, that has to do with horizontal motion, and then vertical motion, which is upward and downward motion. So now we need to bring those things here to actually solve this question. As you can see, there is no angle here. Assuming theta was given to us, then we can actually apply the formula for range. Now, how do we now interpret this question? Let's start from the beginning again. A ball is projected from a height of 20 meters above the ground with initial velocity of 0.4 meters per second. Calculate the horizontal distance moved by the ball before hitting the ground. Now, it will look like this. Okay, it will look like this. Now we're looking for the horizontal distance. Now, to calculate the horizontal distance, we need a formula. Alright, we need a formula, and the formula to do that for horizontal distance will be called S equal UC plus RAT squared. Now, the initial velocity is given to us, but the time is not given to us. So it means that we need to bring another formula to be able to solve this question. Now, when we're talking about height and then hitting the ground, like before hitting the ground, it means it has to do with vertical motion. Now, the question I want to ask you now is it going to be upward motion or downward motion? Yeah, that's correct. Hitting the ground, so it will be downward motion. So for us to get the formula, we're going to use H equal UC, hitting the ground, downward motion is moving with gravity, plus RGC squared. So this for vertical, this for horizontal. Now, the height in the question is 20 equal, please, if you've not watched my video on motion, vertical motion and horizontal motion, please go and watch it for you to get better understanding. Now, when it has to do with downward motion, two things need to be taken into consideration. Number 1, initial velocity is 0. Number 2, the acceleration due to gravity is positive. So, having said that, it means u here is 0, okay, times t plus acceleration due to gravity 10 times t squared. So this will give me 20 equal 1 over 2 times 10 t squared. Alright, so this will give me t squared equal, let's see, 4. Yeah. If you divide this 2 in 10, it's 5. Divide both sides by 5. Okay, let me do it for the sake of some people that will understand what I'm doing. So this is 20 equal 5t squared over 5 over 5. And then we have t squared equal 4. So t equal 2 seconds. I equals to the square root, and this t equals 2 seconds. Now, take note, the square root of a value is always as opposed to enters square root. So the square root of 4 is plus or minus 2 seconds. But definitely you can be taking negative seconds. So because I have to take t is equals to 2 seconds. Alright, now we've got t the value for this. Now we can now solve this. Now the horizontal distance now equal s equal u, which is the initial velocity, is equal to 0.4 times t is 2 seconds. Now take note for this projectile, the acceleration here is 0. So acceleration here is 0. So everything here is not needed. Okay? So s equal to 0.8 meter. Okay, that is all concerning question 1. Now to question 2. Now a missile is projected. Sorry, my parabolic shape is not perfect. Okay. With a velocity of 250 meters per second, so u is equal to 250 meters per second. Okay. With an angle theta to the vertical, please take note of the word to the vertical. So this angle here is to the horizontal. This angle here is to the vertical. Theta. Even to that time of flight of the missile is 25 seconds. Total time of flight. That's t, capital T, equal 25 seconds, which is equal to 2u sine theta over g. Yeah. Oh, you remember that formula? Okay, so now they ask us what's the value for theta? What's the value for theta? Now, I want you to note something that when it comes to angles, I'm going to do a comprehensive lesson on resolution of vector. One thing that we need to pay attention is every angle has to be to the horizontal. If it's to the vertical, then resolve it back to the horizontal. Every value, I repeat again, has to be to the horizontal, not to the vertical. You get it? So if here is theta, it means everything here is 90 minus theta. If here is 60, here is 30. If here is 20, here is 50. If here is 70, here is 20. Please, we need to take note of that. Every angle is to be horizontal. So let's dive into this. So we have 25 equal 2 times 250 sine theta over g is 10, g is 10. Okay, so this will give me this 250 equal 50 sine theta. So this will be 50. This will be 50. So what we have is sine theta equals 0.5. Alright. That's 1 over 2, 0.5. So theta equals sine inverse of 0.5, which equal 30 degree. Okay. Now the question is theta 30 degree? Now the funny part of this is when you're solving objective questions, a very good examiner will put the value for theta to be 30 in one of the options, and you might click or select 30, you're wrong. I just told you that every angle has to be to the horizontal. So to find the value for theta now will now be 90 minus 30, which equals 60 degrees. So the angle of theta is 60 degrees, not 30 degrees. Remember, every angle has to be to the horizontal. Now, on the projection is 100 meters per second. Calculate okay, we have so many things to calculate. Now, let's interpret this in a diagram. So, we are having top of the tower, we are having projected upward, we are having angle, we are having the height of the tower, and then we are having the point Q, and then we have initial velocity of 100 meters per second. Okay, let's draw this. Okay, so this is the tower. Okay, and the height is 100 meter. 100 meter. Okay, now it's projected upward with angle. Okay, let's say this is the projection, and the question says is the ground at point Q. Okay, so since we're having a point Q, that means we need to label some other parts so that we will not get confused. Okay, the angle of the projectile, so we are having this. Now the angle will not be here, it will be at the point where it's projected, 30 degrees. Okay, what other thing? Okay, we have initial velocity U equal 100 meters per second. Okay, so I think that's all. All right. So let me put this place. Let me put it as point P. We also need the maximum height. Well, as we proceed in the question, we will be labeling other parts. Now let's dive into the question. The maximum height of the stone above the ground. The maximum height, we're looking for this height. Now, we're going to imagine everything here does not exist. Everything here does not exist. Just imagine we are just having this part. And this is very, very simple. We simplify this projectile in its full sense, which we've done initially. So let us find the height here. So to find the height, a maximum equal u square sine square theta over 2g. Now u is 100 square sine square 30 over 2 times 10. So the A maximum give us alright, 100 square will give me 10,000, and then I'm having 0.5 square That's sin 30 is 0.5 over 20. So this should give me, I'll just go straight and just 0.5 squared, 0.25 times 10,000 divided by 20. So 125 meters. Now we are asked to find the maximum height of the stone above the ground. This from here to here, 125 meters. This is not above the ground. Now we have the height of the tower, which is 100 meters. So now the height of everything above the ground would therefore be 100 meter plus 125 meter equal 225 meter. Alright, so that's the maximum height of the stone above the ground. Now the time of flight. Let's take them together. The time of flight, the time taken to reach the maximum height. Those here, there are two different questions. The time of flight. Okay, so let's find the time taken to reach the maximum height. That should be 3. That's small letter t equal u sine theta over g, which was 100 times sine 30 over 10, which is 100 times 0.5 over 10. So this will give me 5 seconds. So I believe so. Yeah. All right. So the time of flight, calculate t, which is equal to 2 time to reach the maximum height. If you can look at it, this is the time of flight. So is therefore 5 times 2, which is equal to 10 seconds. Alright, I'm going to take that year 5. Now we will have to do serious calculation when it comes to this question, which is question 4, the horizontal distance from the foot of the tower to point Q. So let's call the foot of the tower, let's call it A. Let's call it A. So we're looking for the distance from A to Q. Now, to calculate this, we need to know the time taken for everything. What is the time taken it took for a stone to move like this, move like this, move like this? What is the time taken? If we can find the time taken, then we cannot find the horizontal distance. Why? This is the formula. Alright, so let's find the height from point and call it M. What is the time taken from M to Q? But first of all, let me ask you, what is the time taken from B to M? That is the time to reach the maximum height, which is 5 seconds. What is the time from M to P? It's the same thing, 5 seconds. Time of flight, 5 seconds. So like this and this is 10 seconds. But the question now I'm asking, what's the time taken from M to Q? How do we find it? Now, do we know the total height? Yes, we know the total height. We know the total height is 225 meters. Now to calculate the time taken to reach this point, then we're going to be using this formula. Okay, so let's dive into this in proper. Please, I just want you to follow me. It's not complicated. It's just very, very simple. All we just need to do is to find the time, and then we can now find the height. The height is 225 meter. Okay, having said that, it means this is falling. This is what? This is falling down. So it means downward motion, u equals 0 meter per second. And then g equals 10 meter per second squared. Alright, it's positive. Okay, so let's put this inside the equation. H equals u t plus r gt squared. So H is 225 equal, everything here is 0. So 1.2 times 10 times t squared. Please, this formula is very important in projectile. Very, very important. You notice we've been using this. It's the right of this, knowing that u is 0. Okay, so t squared now will be 225 divided by divided by 5, please. 2 in sum 1 in 10 5. So I have divided both sides by 5. So I'm having 225 divided by 5 equal 45. 45. So we're looking for t. T now is equal to the square root of 45, which equal 6.71 seconds. 6.71 seconds. Let me go again. That the time taking from here to here. This is the time taking. Time from M to Q. This is the time taken from M to Q. Now, the total time of everything, the total time for everything will be the time taken from B to M plus B to M plus N to Q. So B to N is 5 plus 6.71 equal 11.71 seconds. So the total time for everything is 5 plus everything here is 6.71. So this is the time taken. Now to calculate the distance, the horizontal distance. Now we know velocity equal distance over time. So if I will cross multiply, it means distance equal velocity times time. The question now is, what is the velocity? Everybody will say the velocity is 100. That is correct. But remember, I said from the beginning that every line that is not vertical or every line that is not standing or sleeping is confused. Is either a human being is standing or a human being is lying down. A human being cannot be tinted like this and walking on the road. You understand? So every body that is walking like this is actually quote unquote abnormal, and we need to resolve their problem. Now, resolving their problem will now take us to resolution of vector. So it's either you're standing or you're lying down. If you are not standing, you are not lying down, then we need to resolve it. And we resolve in several ways. Please, I'll watch my video on resolution of vector in a way to understand. Now, the question now is, this 100 meter is tilted. Now, is either we resolve it to the vertical or resolve it to the horizontal. Now, the question now I'll ask you is, are we resolving it to the vertical or are we resolving it to the horizontal? If you are saying the vertical, you're wrong. If you're saying the horizontal, you're correct. Why? Find the horizontal distance. to resolve this to the horizontal, we'll be making use of cos. Because I said, if you are resolving to the vertical, you make use of sine. If you are resolving to the horizontal, you make use of cos. Now, you want to know the reason why, please go and watch the video. So this at this point now, we're not going to be using v, we'll be using distance equal u cos theta times time. U is 100 cos 30 times the time taken for everything is this. So this should give us cos theta root 3 over 2 0. And then just go straight to points times 0.8660 times 11.01. Alright, so distance for everything. Alright, 100 times 0.866 times 11.71. Oh, we are our distance, our horizontal distance as 1114.086 meter. Okay, that's all about this question. But some people will be asking, sir, we are asked to find the horizontal distance from the foot of the tower to point Q midway. How do we now make use of range? We will not make use of range for a long time. Okay, I think we should make use of range. Let's see if we have the same answer. Now, to make use of range, then we need to do something. Now, I'm going to draw this for better understanding. So we are having this, right? We are having this. This is projectile on itself, so we can find the range. But the problem now is there will be a little problem here. So let me label this place as C. Okay, so vector is telling us that AP is the same thing as AC. Alright? They're just the same thing like a rectangle. So let's find BP. To find BP, now this is an alternative way of solving it. To find BP, that is the distance of BP will actually be our range, which is R equal U squared sine 2 theta over G. Okay, so U is 100 times 100 squared times sine 2 times 30 over 10. So this will give me, let's go straight. This is sine 60. Sine 60 is as cos 30, which is 0.8660 times 10,000 divided by 10. So this the distance here is, let me use quantity D. Distance of BP equal 866 meter. All right, that's very good. Now the question now is how to find the distance for these points. First of all, let's find the time. What the time taken from M to Q? M to Q. Let's find it. Yeah. M to Q, that's 6.71. Now, if from M to Q is 6.71, what from M to P is 5. Please follow. M to Q 6.71. M to P is 5. We established that fact long time ago. So if it's 5, so the time taken from P to Q is what? Time taken from P to Q, time taken from P to Q will now be M to Q minus MP. So M to Q, let's go 6.71 minus 5, which will give me 1.71 seconds. Now with the found time, you know we can find it. We can find the distance. Yeah. So it's very straightforward to find the distance. Okay, so yeah. It's just like what we've been discussing since. So this d now will be u cos theta times time. Remember, everything we're finding here is the distance from CQ. We found AC. What is AC, please? AC is the range. BP is the same thing as AC. Okay, so we want to find CQ, this very small one. So it will now be 100 cos 30 times. What is the time for CQ? For CQ, this is very small time taking, which will be 1.71. Okay, so that's 0.866 times 100 times 1.71. Okay, I'm having 148.086 meter. So now the question now is what is the horizontal distance? The horizontal distance is now the distance of what? AC, which is same as what? The range plus the distance of CQ. Okay, now let's add it. Distance of AC now. Where's the range? 866m plus 148.086 meter. Alright, so now the horizontal distance now for everything should give us the same answer. It's not the same answer. It's correct and correct. It's wrong, you're wrong. Right, that's a joke. Okay, we're correct. So the horizontal distance now is 1,114.086 meter. Sharp. Alright, so that's all about projectile. If you have any question or anything you want to say, just leave that in the comments side below. Please like, share to your friends. Tell your friends about me this tutorial, and then please subscribe and click the notification bell to get notified of the latest video on YouTube tutorial. Thank you very much.